Hello everyone, my name is Khushbu Shalke and in this video I will be presenting my machine learning major project titled Sales Prediction using Multiple Linear Regression. In this project I will explain how we can predict product sales using different advertising platforms such as TV, radio and newspaper. Companies spend significant amount of money on advertising through different media. However, one common question is which advertising platform contribute the most to the sales? Instead of making decision based on assumption, we can use machine learning to analyze historical data and predict future sales. So let's get started. The objective of this project is to build a machine learning model that predicts sales based on advertising expenditure. Now, let's move to the coding section. First, I have imported all the required Python libraries. Panda for handling dataset, NumPy for numerical operations, Matplotlib and Seaborn for data visualization, Scikit-learn for building and evaluating the machine learning model. Next, I have loaded the dataset using Pandas. After successful loading, I have displayed first few rows to understand the data structure, then printed df.info for informations like number of columns, missing values, data type, etc. In this step, we visualize the relation between each advertising medium and sales using Seaborn pair plot function. From these plots, we can observe that TV advertising has the strongest positive relation with sales, followed by radio and then by newspaper. We can tell that by observing which plot makes the most straight line type of figure. After that, we have imported the linear regression class through Scikit-learn, which we will use to build multiple linear regression model. Next, we have separated our dataset into input feature and the target variable. Next, this line creates an empty multiple linear regression model. Training the model, then displaying the intercept. Intercept is the predicted sales value when all advertising expenditure are zero. It represents the constant term in regression equation. Coefficient, display of coefficient. The coefficient indicates how much the predicted sales change when a particular advertising budget increases by 1 unit, while keeping the other variables constant. Here, we store the names of all independent variable in a list so that we can match each coefficient with its corresponding feature. This line stores all the learned regression coefficient into a variable. The zip function combines each feature name with its corresponding coefficient and dict converts them into a dictionary for easier interpretation. Display of dictionary. In this step, we use a heat map to visualize the correlation between all the variables in our dataset. The closer the value towards 1, the greater the correlation. Here we can observe sales and TV has the highest correlation, followed by newspaper and then by radio. In task 5, first we have imported the R2 square function. The R2 square tells us how well our model explains the variation in the sales data. A value closer to 1 indicates better model performance. In model 1, using TV and radio, here we select only the TV and radio advertising budget as input feature. We intentionally exclude newspaper to see whether it contributes significantly to the prediction. Created the model, trained the model, making the model to predict the sales. After that, we have calculated R2 score for it. In model 2, now we include all the three advertising channels as input feature. Created the model, trained the model, and making it predict the sales. Then we have calculated the R2 score for all features. If we compare both the results, we can say that TV and radio are the most important feature for predicting the sales. In task 6, instead of evaluating the model on the same data used for training, we split the dataset into training and testing sets. This helps us evaluate how well the model performs on unseen data. Here, X contains all input features while Y contains target variable sales. Splitting the dataset. The data is divided into training data and testing data. We have trained the new linear regression model LLM4 on training X and Y. Then we have used it to predict for X test. Now we are calculating RMSE value, that is root mean square. It gives us the average prediction error. And we have also calculated R2 score for it. Then secondly, we have used model using TV and radio, and again do the same steps. If we compare model using TV and radio and model using all the features, we can see RMSE value for using TV and radio is lesser than the model using all the features. And R2 score is also higher than the R2 score for all the features. That means the model using TV and radio is more accurate than the model using all the features. Till now, we have only used numerical matrices to compare our LLM models. In this step, we are using Yellow Brick library to visually evaluate our machine learning model instead of only looking for numerical matrices like RMSE and R2 score. We use graphs to understand how well our model is performing. Here we have created prediction error visualizer using our trained linear regression model LLM5. This graph compares the actual sales value with the predicted sales value. The visualizer is fitted on the trained data so that it can learn the model's prediction. Next, we have evaluated the data on testing dataset. This checks how accurately the model predicts unseen data. Finally, we have displayed the prediction error graph. If the most of the point lies closer to the identity, then it shows that our model is performing well. In task 8, intersection effect or synergy effect. Sometimes two features together have a stronger effect than either functions individually. This is called an interaction effect or synergy effect. In our project, we are creating an interaction feature by multiplying TV with the radio budget. This line has created a new feature called TV radio intersection, which is simply the product of TV and radio advertising expenditure. Now, we have three input features: TV, radio intersection, and output that remains sales. Splitting the dataset, creating a LLM model, the name of that is intersection model. Fitting the model with our training dataset, making it predict the sales for testing data, then calculating RMSE and R2 score for it. Finally, we visualize the performance of interaction model using prediction error graph. As we can see, the points are less scattered around the identity. By comparing these graphs and evaluation matrices with the previous model, we can determine that interaction features improves the prediction performance. Like here, the R2 score is 0.9789, and for this it's 0.979. That means the R2 score for that is closer to 1. So the inter interactive model is more accurate. And also by RMSE, here the RMSE value is 1.387, and for the interaction model it's 0.70. So the lesser the RMSE, the better the model is. And also by the prediction graph, we have said that our interaction model is more accurate than the previous one. To conclude this project, we build a multiple linear regression model to predict product sales based on advertising expenditure. We started with exploring and visualizing the data, then trained the model and interpreted the regression coefficients. Next, we performed feature selection and found that TV and radio advertising were the most influential features, while newspaper contribute very little. We evaluate the model using RMSE, R2 score, and prediction error plot to ensure its performance well on unseen data. Finally, we introduced an interaction feature between TV and radio to capture their combined effect on sales and compare its performance with the previous model. This project demonstrates that the complete machine learning workflow, from data analysis and model building to evaluation and performance improvement using multiple linear regression. Thank you so much for watching my video.